Hello there, my name is Benjamin Fontaine, and this is my solar light. So, the reason why I'm doing this, actually a couple of reasons. One, we had to pick an ethical concern. I chose solar power. Figured one out. Another reason is my cousin is the co-founder of an organization called Tree of Hope Haiti. Ironically, I am wearing one of their shirts. Totally didn't plan that. But she got the idea, so I asked her if there's anything I could do to help, and she said, why not build a light that would go to a family that would need it. So I did that. So this is my system diagram. Needs to be updated, but basically, here's the sun. It's going to go down, and the solar sensors, light sensors are going to look at it, and they're going to control the solar tracker. So what they do is there's one here, there's one here, and say the light's over there. The solar lights are going to be like, oh, or solar sensor is going to be like, oh, the sun's over there, and it's going to kind of turn the motor in the solar tracker, which also mounts the solar panel. Solar panel is going to collect energy from the sun. It's going to go straight through the solar charger to give it a constant charge to the batteries. And the batteries are going to control, there's going to be a switch. We can turn on the motion sensor and the LEDs. So some features, it's going to charge the battery during the day. Lights the LEDs at night. It's going to use an Arduino Nano to, as I said, because it controls the brain of the solar tracking circuit. Light sensors. Yeah, so light sensors are there to face the sun, as I previously stated. It's got motion sensors. So some specs. So I have two 2 amp hour batteries in parallel. That gives me 4 amp hours, or 4,000 milliamp hours, if you want a big number. They're 3.7 volts each. I have a boost converter to go from the 3.7 volts to 5 volts so that the Arduino will work. I've got a 2-watt B-type solar panel. So I guess there's 3 types of solar panels. There's A, B, C. A being like the best of the best but the most expensive. C being the not so great but they're cheap. And B type's somewhere in the middle. And I found out the LEDs that I am using, I got prepackaged LEDs for the purpose of prototyping, and they output 115 lux. For those of you who don't know what that means, lux is the unit that, it's basically how much light is in a given area. It's enough to light up a 12 by 12 room. So this is my overall circuit. I know it's kind of hard to see, but bear with me. So we have the batteries here. It's going to come up. Here's the switch. It's 3.7 volts right now, so say it goes into here. And it's going to go into these motion sensors and kind of make sure that there's somebody there before they turn on. And then they're going to come down to the LEDs. LEDs are going to turn on, and the motion sensors test. Motion sensors find that there's motion. Later on, I'm going to find a way to get the LEDs to kind of slowly turn off so that it's not an instantaneous, I'm off. But that's coming up. Again, for the purpose of prototyping, this is all the prepackaged LEDs that I got. Alright, so say the switch is off. It's gonna, the volts are gonna go right over here to the boost converter, which again, 3.7 volts, 2.5 volts, turns on the Arduino, and this powers my solar tracking circuit. I'm going to talk about that more in a little bit. And then it's going to kind of face where the solar panels are going to go, and from here, the solar panel, where it faces the sun, is going to start charging. It goes into the solar regulator, and actually if you want to hit that, solar regulator, and it's going to go and charge the batteries. Here's a more, so that you guys can see what these, where everything is. So a solar tracker. So we got 5 volts coming in from the Arduino into this. It powers the motor, and also, let's see. So it's got, let's see. Well, it powers the motor. Motor's controlled by a, is that digital? Yes. By a digital pin so that it can spin. And these photoresistors, they're gonna, they're gonna compare the voltages between, hence how they see the sun. And they're gonna spin the motor and try to make it so that it's equal. I still have yet to make my code do that. We'll get there. The circuit in the original code is from the Code Project Open License, which I found on the internet. I'm not using the original code, just their circuit. Speaking of code, so basically all my initializations and what's it called? Variables are up here. I have my setup, so I output all my pins. These are the motor pins. Those are the pins for the sensors, the solar or I said this like 3 times. The solar sensors. Okay, so the serial begin 9600 is so that it controls the baud rate, so that I can find the values of the sensors, so that I can best figure out how to code the way it needs to be coded. So like, basically it tells me the values of each one, and so I can, yeah, okay, you got it. What else? That prints the values. Alright, so I have the, here we go, motor control down here. Alright, so if one value is, so if the right value is greater than the left value with a, plus or minus 5, it's going to turn the motor in the counterclockwise direction. And if it's the other way, it's going to turn the other way. And motor control is basically so that the motor will actually spin. There's more code on the bottom, and that just controls how the motor spins. So cost of what I ended up spending. So we have the solar regulator, the thing that gives a constant charge to my batteries. That cost me about 20 bucks, and took forever to get here, by the way. Solar panel cost about 8 bucks. The photoresistors, the servo motor, and what was the other thing? I guess that was it. Yeah. Those were in the lab, and I was able to just use those. The 2 batteries cost 20 bucks. Well, a pack of 4, and I only used 2, so really 10, kind of. And the packaged LED lights for prototyping cost 15, and those have motion sensors in them. So, there's that. Total of 70 bucks for that. So here I have a video of my working circuit, if you want to kind of find the arrow down here. Nope.
Hover over the picture.
If you just put the
Alright, looks like it's recording. So this is my entire circuit. As you can see, we have the solar panel here, solar regulator, batteries, Arduino, and the lights, and the motor. Oh, what's that? The lights aren't working? Well, whoosh. Yeah, they're motion sensing. Pretty awesome. What was I going to say? Alright, so that's when the switch over here is for when the lights are to be turned on. I'm actually going to switch it to this guy right here because I like it better. It's more durable. But for the purpose of building the circuit and testing, I use the little guy. So then we switch it. This is to turn the lights off. and it turns the Arduino on, spins the motor. Now I'm going to code the Arduino to only spin the motor when those two sensors, if you can see them probably, when those two sensors, like basically when they're not of equal resistance, so in other words, if one can see the sun more than the other, and in terms of when it's fully built, those sensors are going to go on that solar panel up top. So yeah.
And that's it. Any questions?
Um,
Mr. St. Dennis, do your worst.
On your cost slide, can you go back to the costs? So you've got 0 for photoresistors and small servos. Did you look up any prices just to see what it would cost to?
Yes, so the photoresistors, I think they were around like $1 or $2. And the motor, what was it? Don't remember how much the motor was, but it was like less than 10. Less than 10.
Or less than 10?
Yeah. Aaron, you had a question?
Yeah, just when you were talking about the amount of light in an area, you refer to it as lux instead of lumens. Why?
Yeah. That's,
What's the are the two terms synonymous?
well, kind of. Lumens is like a beam of light, and lux is like overall, like in a general area,
Ah,
as far as I.
Any other questions? Actually, go back to the solar tracker circuit.
Oh, here.
That's something written down here. All right. The little circle on the left is the motor.
That's the motor, yes.
Okay, what's that wire leading off to the left of it?
This?
Yeah, where's that?
That
go?
goes to the digital pin
Okay. So is that,
of the Arduino, so that it can control where it's, so that it control like where it spins, when it spins, and all that.
okay. But when we saw the video,
Mhm.
the Arduino was connected to a circuit board,
Mhm.
and there were 4 LEDs flashing. So,
Oh, that's the
where are the 4 LEDs?
that was the thing for the, because the servo motor comes with the other little part there. That,
Yeah. So,
or if you wanna go forward to the video, that I can.
yeah, there's a control board.
So this little guy right here is a part of that motor, because like they're all like, so the motor plugs into that, and then that.
How many wires connect between that and the Arduino?
4.
4, okay. So, I think what you were showing on your first circuit was maybe an earlier design where you were using a 1-wire servo, like they do in RC airplanes and RC cars. This is a 4-wire stepper motor setup.
Okay.
And my recollection is we sat down and we looked at the total current requirement,
Mhm.
and which was better?
The,
That one.
no.
Right. That took less current, even though it took 4 wires, it took less current to run, and you could shut it down anytime you wanted.
Right.
And you couldn't do that with the servo system. So I don't think you updated that first schematic
No.
to reflect this.
Blake, you had a question?
He answered
All right.
Any other questions? All right, thank you.